Hello friends, a very warm welcome to the discussion of our topic, cubes and cuboids, on which questions have appeared in previous years' CSAT examinations. Now this topic is very interesting, wherein you would see a cube being cut into various pieces, and then the various faces of the large cube would be painted with different colors, and then questions will be based on that. Now let us first of all have a look at the very basics pertaining to cubes. So in a cube, there are 6 faces, 8 corners and 12 edges. Now this is a very important information that you have. So this is how a cube looks like. Now these are the various faces, as you can see. This is top, opposite to that is bottom. This is left, opposite to that is right. This is front, opposite to that is back. So a cube has 3 pairs of opposite faces, top and bottom, front and back, left and right. Then there are 8 corners as are visible here. Now what is a corner? Corner is a point where 3 faces of a cube will meet. Now similarly, there are 12 edges. What is an edge? Edge is that line, as you see here, where the 2 faces of a cube would meet. All these lines, as you can see here in this diagram, are edges, and there are 12 edges in all. So this is a very important information that you have, and that is, please remember, 6 faces, 8 corners and 12 edges are there in a cube. Now in a cube, if n cuts are made in the same direction, then the number of pieces obtained will be n plus 1. Now what do I mean by that? Now see, let us say that we have a cube here, and we make one cut to this cube, that is vertically perpendicular, like this. So the number of pieces that we get with one cut made, we are getting 2 pieces, 1 and 2. Now look at another case. This is a cube. Now let us make 2 cuts to this cube. Again, in the same direction, both the cuts would be parallel to the same pair of faces. So we will make these cuts vertically perpendicular, like this, 1, 2. So this is one cut, and this is the second cut. So the number of pieces are going to be 3. Now let us take another case, another cube, to which we make 3 cuts, vertically perpendicular. Once again, all the 3 cuts are made in the same direction, 1, 2 and 3. So let us say this is 1, this is 2 and this is 3. Now the number of pieces obtained are 4, as you can see. See, 1, 2, 3 and these are 4 pieces. Here we had 1, 2 and 3 pieces. So from this, what we learn, 1 cut, 2 pieces, 2 cuts, 3 pieces, 3 cuts, 4 pieces. So for n cuts, number of pieces is n plus 1. That is, the number of pieces obtained is 1 more than the number of cuts. So to a cube, if at all, let us say we make 100 cuts, but all the cuts should be parallel to each other and each parallel to same pair of faces. Or so as to say, every cut is made in one single direction, like this. That is vertically perpendicular. So 100 cuts made to a cube in such a way would result in 101 pieces, that is 1 more than the number of cuts. Now what will happen if we change the direction of these cuts? Now let's take a cube here. This time we are going to make 2 cuts to this cube. One vertically perpendicular, second horizontal. So one is vertically perpendicular, the other is horizontal. Now the number of pieces here are 1, 2, 3, 4. So we get 4 pieces. Let's take another case. Now we will make 3 cuts to this cube, but these cuts are not going to be parallel to each other. Each of these cuts would be made in a different direction. So let us say this is the first cut, that is vertically perpendicular, like this. Second cut, that is horizontal. And third cut, which will be vertically parallel. So this way, the number of pieces have become, let us say, look at the top, you have 1, 2, 3, 4 pieces at the top, and you have 2 such rows consisting of 4 pieces each. So that gives us 8 pieces in all. Now see, when 2 cuts were given in the same direction, in that case, the number of pieces obtained was 1 more than the number of cuts. So the number of pieces were 2 plus 1, that is 3. Similarly here, if all the 3 cuts were made in the same direction, 1, 2, 3, like this, then the number of pieces would have become 3 plus 1, that is 4, if all the 3 cuts were made in the same direction. But since we have changed the direction or the axis or the plane parallel to which these cuts are being made, the number of pieces has increased. Similarly, have a look at this example. That is 6 cuts. If we want to give 6 cuts to a cube, and all these 6 cuts are made in the same direction, let us say vertically perpendicular, like this, then the number of pieces obtained would be 6 plus 1, that is 7. Whereas if you want to maximize the number of pieces produced, then you would distribute these 6 cuts as equal as possible in 3 different directions. So 6 divided by 3 would give you 2 cuts to be made in 3 directions. And we will consider only 3 directions. Which are these 3 directions? Vertically perpendicular, horizontal, and vertically parallel. That is facing you. So this is vertically perpendicular. 2 cuts are made. Then horizontal is what we have. And then vertically parallel, like this. There you go. Now look at the number of pieces. Now look at the top. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are 9 pieces at the top, and you have 3 rows of 9 pieces. So 9 into 3, you will get 27 pieces. Whereas if all the 6 cuts would have been made in the same direction, let us say, then the number of pieces obtained would be 6 plus 1, that is 7. Now 27, as you can see, is greater than 7. So in a cube, if n number of cuts are made, then in order to obtain the maximum number of pieces, the n cuts should be distributed in 3 different directions as equal as possible. Now what do we do if we have to make 10 cuts? How would you distribute these 10 cuts? Well, as I said, divide the number of cuts as equal as possible in 3 different directions. Now see, 6 and 3 are multiples of 3. So we could easily divide these cuts as per the quotient you receive when you divide 6 and 3 by 3. But for 10, when you divide 10 by 3, you get 3 as the quotient and 1 here is the remainder. Well, in such a case, you will distribute these cuts as equally as possible in 3 different directions. That is 3 plus 3 plus 3, which becomes 9, plus 1 in one direction, which will make this 4, so that the difference between the number of cuts made in any 2 directions remains the least, which is 0, or let us say 1, as minimum as possible. So here, what we will get will be a 4. So 3 plus 3 plus 4. See, the difference here is 0. Difference here between these 2 number of cuts is 1. Whereas if we would have made all the 10 cuts in the same direction, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all vertically perpendicular, then the number of pieces obtained would have been 10 plus 1, that is 11, which is the least number of pieces produced. So you want to maximize the number of pieces produced, so distribute the number of cuts as equal as possible in 3 different directions. If the number of cuts is not divisible by 3, then distribute the remainder as equal as possible to the cuts made in the various directions. Now, my question is, what would be the maximum number of pieces produced by making 10 cuts to a cube? Well, we already know that in this direction, we have made 3 cuts. Let us say 1, 2, 3. All these 3 cuts are made in the same direction. So here, we will get 1, 2, 3, 4, that is 4 pieces. So that is plus 1. Similarly, 1, 2, 3. Horizontally, we have given 3 cuts. So 1, 2, 3, 4, there would be 4 pieces produced. That is again 1 more. Now, let us say that 1, 2, 3, 4, we are making 4 cuts vertically parallel. Number of pieces produced again is going to be one more. So the total number of pieces produced, let us say in this direction will be 4, in this direction will be 4, in this direction will be 5. As these are the number of pieces produced in 3 different directions, we will multiply them. So 4 into 4 is 16, into 5 is 80. So 80 is the maximum number of pieces that can be produced by making 10 cuts to a cube. Now let's take another example. What about 11 cuts? 11 again when divided by 3 gives us the quotient 3, goes by 9, remainder 2. So as it is, 3 plus 3 is how we distribute them equally. But that makes it only 9. Now remaining 2 cuts we would distribute to any 2 directions, plus 1 here. So this will become 4, this will become 4. So the distribution now becomes 3 plus 4 plus 4. This is how we will divide these 11 cuts to maximize the number of pieces produced. Once again, if all the 11 cuts are made in a single direction, the number of pieces produced would be 11 plus 1, that is 12. Whereas here we want to maximize the number of pieces produced. Now once again, 3 cuts or 4 cuts, any number of cuts which are made parallel to the same pair of faces will result in the number of cuts plus 1 number of pieces. So 3 plus 1, 4 plus 1, 4 plus 1. These would be the number of pieces produced in various directions. So 3 plus 1 is 4, 4 plus 1 is 5, 4 plus 1 is 5. So we will multiply these because these are number of pieces produced in 3 different directions. So 4 into 5 is 20, 20 into 5 is 100. So 100 pieces would be produced by making 11 cuts. Now you may be asked that what is the maximum number of pieces that can be produced by making 11 cuts to a cube? You obviously are not going to draw a diagram. It will be a waste of time. So simply this is how you will use the method and get 100 pieces as the answer. Now for any number of cuts given to you, be it a multiple of 3 or a non-multiple of 3, you would be in a position to find out the maximum number of pieces. Now let us take a case which is just the vice versa. By that I mean, what if you are asked a question that what is the least number of cuts required to produce 100 pieces? See, previously our question was, what is the maximum number of pieces that can be produced by making 11 cuts? We know the answer here is 100. Now, just the reverse of this. What is the minimum or least number of cuts required to produce 100 pieces? See, maximum number of cuts would be how much? 100 minus 1, 99. All 99 cuts made in the same direction would result in 99 plus 1, 100 pieces. Whereas you want to minimize this, so once again, we will go in the reverse direction. So let us say from 100 pieces, the least number of cuts needs to be found out. So what you would do is, you will try and express 100 as a multiple of a square. Now 100 you know is 10 square. But that gives us only 2 numbers, 10 into 10. The third will be a 1. So it would become 10 into 10 into 1. Now see, if I write it as 10 into 10 into 1, once again the difference here between the number of pieces produced in 2 different directions is quite high, that is 9, 10 and 1. So rather than doing this, let us write it as 4 into 25. Let's expand this. It would become 4 into 5 into 5. Alright, so 4 into 5 into 5. Now you see the difference here is least. 4 and 5 difference is only 1. 5 and 5 the difference is only 0. It is the least. Now go to this particular figure and let's move in the opposite direction. Well, number of pieces is 4 into 5 into 5. Yes, that's where we are right now here on the right hand side top here. Please see. Now from here you are going in the reverse direction. So 3 plus 1 became 4 and these were the number of cuts So if we want to obtain, we will go in the reverse direction. So from 4 we will subtract 1 to get 3 number of cuts in that particular direction which are producing these 4 pieces. So minus 1, minus 1, minus 1. 4 minus 1 is 3. 5 minus 1 is 4. 5 minus 1 is 4. So 3 plus 4 plus 4 is 7 plus 4. That is 11 cuts. So just the reverse process. The only thing that you need to take care of is that these factors of 100 that you are taking here, they should be as close to each other as possible with least difference between any two. So now, how do you find out the least number of cuts for 150 pieces? Again, 150 is 6 into 25. See, 25 is a square here, isn't it so? And in a square, you will get two numbers which are equal to each other, isn't it? So 5 into 5. So 5 and 5 will anyhow maintain the least difference between them, that is 0. And the nearest number is 6. So let me just write this as 6 into 5 into 5. Minus 1 from each of these. You get a 5 plus 4 plus 4, that is equal to 13 cuts. So minimum, least 13 cuts would be required to produce 150 pieces. Maximum cuts would be just one less, 150 minus 1, that is 149. 149 cuts made in the same direction will result in 150 pieces, whereas minimum number of cuts required to produce 150 pieces shall be 13 cuts. So as you can see, here we are going in the forward order, here we are going in the reverse order. So some variety of questions that we have covered here would be like 1. What would be the number of pieces produced when 10 cuts are made to a cube in the same direction or parallel to same pair of faces, or all the cuts being parallel to each other? In that case, our answer is 10 plus 1, 11 pieces. Number 2, if you are asked, what is the maximum number of pieces that can be produced by making 10 cuts to a cube? Now you want to maximize, so we will adopt this process, as you can see here, and our answer will become 80 pieces. What is the maximum number of cuts required to produce 80 pieces? Well, maximum number of cuts would be just 1 less than the number of pieces. So it shall become 80 minus 1, 79. All 79 cuts made in the same direction would result in 79 plus 1, 80 pieces. And the fourth type, what is the least number of cuts required to produce 80 pieces? And here our answer has to be 10 cuts. So I hope this is very clear to you. Alright, now let us have a look at a cube and let's color it and see what kind of questions can be asked after we make some number of cuts to it. Now look at this question. If all the 6 faces of a cube are colored red and then 3 cuts are made to the cube such that maximum number of pieces is obtained, then how many pieces will? Now 3 cuts if you have to make, well, this is how you will make the 3 cuts, isn't it so? This is 1 cut, this is 2nd cut, and this is the 3rd cut. Now see what kind of questions are asked here. So how many pieces will be there in total? Well, we already found out this is 1, 2, 3, 4 at the top, and there are 2 rows, so that makes it 4 into 2, 8. Now one more thing which I would like to add here is, you need not actually draw the diagram. There are some more shortcuts which I would introduce further on as the session moves forward, but currently I just want you to view this cube and register these pieces into your mind and know the positions of these pieces as well. So anyhow, we have 8 such pieces. So how many pieces will have 3 faces colored? Well, when we are talking about a corner, this is a corner. Now you know that corner is a point where 3 faces meet or 3 edges meet. So this would be a 3-facet cube wherein 3 faces of this cube will be visible and the other 3 faces will be covered. Now we are talking about this cube here. So this is the top, this is the front, and this is the right side. Now the left is covered by this cube, back is covered by this cube, bottom is covered by this cube, as you can see here. So 3 faces colored and 3 faces covered. Such kind of cube will be available only if the piece consists of a corner in it. Or let us say if this piece is such that it consists of the corner of the larger cube. So there is one piece here which has 3 faces colored. Well, how many corners are there in a cube? Always 8. And the total number of pieces in this cube will be 8. So each of these pieces, all the 8 pieces, will have 3 faces colored. Now because this cube consists of a corner in it, so let us simply name this as a corner cube. Now how many pieces have 2 faces colored? Is there any piece you can see here which has 2 faces colored? Well, we are not left with any other piece now because all the pieces have 3 faces colored. So this is 0. Is there any piece which has 1 face colored? Only 1 face colored? Well, again not. We have accounted for all the 8 pieces. Each one of them has 3 faces colored. Similarly, no face colored, no chance, 0 again. Now let's have a look at another set of questions for another type. All the faces of a cube are colored white, and then the cube is divided into 27 small identical cubes. So how many small pieces will have? Now this is how the diagram will look like. When you say 27 identical pieces, you know that 27 equals 3 into 3 into 3 minus 1 minus 1 minus 1. That is 2 cuts in each direction, and total number of cuts here shall be 6 cuts. We have already learned how to find the least number of cuts. Now, how many small pieces will have 3 faces colored? Well, you know that this is a corner cube or a corner piece, and it will always be 8 in number because there are 8 corners to a cube. So there will be 8 pieces which will have 3 faces colored. So initially we had 27. We have accounted for these 8. We have identified that these 8 cubes or 8 pieces have 3 faces colored. So now remaining are 27 minus 8, that is 19. We are yet to discuss these 19 pieces. 2 faces colored. Do we have such kind of a piece here? Well, yes. Look at this piece. It has 2 faces colored here. 1, 2. The top is covered, left is covered, bottom is covered, and the back face is also covered. Only these 2 faces are colored. And then, where is this piece found? Such kind of cubes which have 2 faces colored are found on an edge between 2 corner cubes. On an edge and between 2 corner cubes. So there is one such piece on one edge. Now what is the total number of edges? Total number of edges is 12. So there will be 12 such pieces which will have 2 faces colored, or 12 such small cubes which will have 2 faces colored. Now as this cube is found in the middle of 2 corner cubes, let us call it a middle cube. Now this terminology will not be used in the examination. This is something that we will use only for our comfort and for the purpose of discussion. So how many pieces will have 1 face colored? Now where is this piece found? This is the one. We're talking about this piece. See, its top is covered, left is covered, right is covered, bottom is covered, and obviously when you look at the front face of a cube, you cannot view the back face of that cube, because in a pair of opposite faces, only one face can be seen at a time. If you see the front, you can't see the back. Alright, so where is this cube found now? This is on one big face of the large cube. So on one face of the large cube, how many faces are there in total? 6. So there would be 6 such pieces that we're talking about. See, look at this one here in the center. So it is found in the center of a face. So let us call this center cube. You can obtain this by removing the top and the bottom rows and by removing the left and the right columns. Then you are left with only the center cube. Now previously, out of 19 we discussed 12. So 19 minus 12, 7 were remaining for discussion. And now 7 minus 6, 1 cube or one piece still remains for the discussion. Where is this one piece? Well, this one piece is not visible to us. So it is found right in the middle, right in the center of this large cube. And it is such kind of a cube whose all the faces will be covered. None of those faces can be colored. So this cube will be a one which has 0 face colored. So our next question is no face colored. That would be this one cube which is right in the middle. Now where is it? Well, it is right behind this, right below this, again right behind this, somewhere here in the middle, not visible to us. Now as no face of this cube is colored and it is not visible to us, so let us call this as an invisible cube, just for the sake of discussion. Now, what will be the total number of small cubes at the edges? So we know that there are 27 pieces in all, out of which let us subtract this one, because this 0 faced cube, no face colored, is not found on the edges. It is right in the middle. Then apart from that, let us subtract these 6 one-faced cubes. Look at this one, right? This is in the middle of this face, or center of this face. Again, center of the face. Center of the face. It is not along the edges. So we will reduce this as well. So 27 minus 1 minus 6 shall give us 20 as the total number of small cubes which are found on the edges. Look at this one. All the faces of a cube are colored blue, and then the cube is divided into 64 small identical cubes. Then how many small pieces will have? Various questions on that. But first of all, 64 is the total number of identical cubes or small pieces. Now how do you get 64 pieces? By giving least number of cuts. Well, for that 64 is nothing but it is cube of 4. So 4 into 4 into 4. Minus 1 from each of these. It is 3 plus 3 plus 3. That is 9 cuts in total. So 9 cuts are supposed to give you 64 pieces. So we will make 9 by 3. That is equal to 3 cuts in each direction. We will get this kind of a figure. See the cuts here. 1, 2, 3. Vertically perpendicular. Then 1, 2, 3. That is horizontal. And then 1, 2, 3. That is vertically parallel. Now look at the question here. How many small pieces will have 3 faces colored? Well, always 8, without doubt. So it is always 8 because there are 8 corners. So these 3 faces colored will be the corner cubes, and there are always 8 corners to a cube. So these are corner cubes, which will always be 8. 2 faces colored, where are these found? Along an edge between 2 corner cubes. So these are 2 corner cubes, let us say. So these are the 2 cubes here which have only 2 faces colored. So 2 cubes on one edge. What is the total number of edges? That is 12. So 12 into 2, 24 number of those pieces which will have 2 faces colored. Once again, these are 64 pieces in total. So 64 minus 8, because we have discussed 8 here, we are left with 56. Then 56 minus 24, because we've identified that 24 pieces have 2 faces colored. So it shall become 32. And the next question says 1 face colored. Where are these found? These are found right in the center of a face. And how they are found? Remove the top and the bottom row. Remove the left and the right column. So let us say when we remove this top and bottom and left and right, then we are able to find out these cubes which have only one face colored, and these are 1, 2, 3, 4 in number. So 4 on one face, number of faces is 6, so 4 into 6 shall become again 24. 24 more cubes found out of 32 in discussion. So 32 minus 24, we are still left with 8 cubes or 8 small pieces to be identified. And where are these? Well, these are those which have no face colored. These are invisible cubes which are 8 in number. So that's where the story ends. But the next question says, how many small pieces have at least 2 faces covered? At least 2 means what? 2 and more than 2. So it would mean 2 faces colored and 3 faces colored cubes. So 2 faces colored we already know here is 24. 3 faces colored, we already know that these are 8 in number. So 24 plus 8, we should get 32 cubes. That is by combining the number of cubes in question number 11 and 12. Now, is there a shorter method of finding out these details? Well, what if I ask you all these details when a cube is divided into 1,000 pieces? Well, it will be very difficult for you to draw the diagram in rough and then watch out for all these details. So, this becomes handy because now you know the position of one face colored cubes, the position of 2 face colored cubes. Corner cubes are anyhow going to be in corner. So this should be there in your mind, that what is the position of each of these types of cubes. Now, looking carefully, you would find that number of pieces on an edge, if I take it as n, which can be found out by using the formula total cuts by 3 plus 1. There is no formula actually. See, the whole point is, I'll give an example here. Let us take a cube and let us give 3 cuts in each direction. So this is how it will look like, somewhat like this. Now let us take a cube to which we are giving 9 cuts, that is 3 cuts in each direction. Here we go. And now let us find out these details. It is there in front of you. The value of n that I am asking you to find out here is total cuts. Total cuts is how much? That is 9. Divide by 3 will give you the number of cuts made in each direction. That is 3 cuts are made in each direction. Plus 1, that is number of pieces on each edge. So 3 is the number of cuts you have given like this. How many pieces will you get? All 3 cuts made in the same direction. 1, 2, 3, 4. So that is the value of n. Now simply, if you want to find out, well, from here to here you have n number of pieces, that is horizontally, then vertically here you have n number of pieces, then once again like this you have n number of pieces in 3 different directions. So n into n into n, that is total number of pieces will be n cube. 3 faces I have discussed with you, it will always remain 8. Those pieces whose 3 faces are colored or whose 3 faces are visible and the other 3 are covered will always be 8. Now 2 faces, as I told you before, the destination of these 2 faces or the address of these 2 faces colored cubes will be, they are between corner cubes on an edge. So they are on an edge between 2 corner cubes. So these are the ones that we are talking about, those which have 2 faces colored. Now as it is, the number of pieces on an edge you know is n. So from n we are subtracting these 2 corner cubes. So on one edge there will be n minus 2 number of 2 face colored cubes. And how many edges are there in total? Well, so on each of these 12 edges there would be n minus 2 number of pieces. So hence the total number of pieces which have 2 faces colored can be found out using the expression or the formula, that is 12 into n minus 2. One face colored. One face colored, where are they found? Well, I told you, you can remove the top and the bottom row. So this way 1, 2, there will be only 2 pieces left in any column. If you remove the top and the bottom, in between there will be only 2 pieces left. Or let us say that each row and each column consists of n number of cubes. So if you remove the top row and the bottom row, in between you will find n minus 2 number of pieces. So removing top and bottom, in between n minus 2 remaining. Now similarly removing the left and the right column, in between n minus 2. n minus 2, n minus 2, n minus 2 into n minus 2 will be the total number of one face colored cubes on a single face. So that gives us n minus 2 whole square number of one face colored cubes on a single face of a large cube. Now how many faces are there? Well, we know that there are 6 faces to a large cube. So on each face n minus 2 whole square number of one face colored cubes. So on 6 faces, 6 into n minus 2 whole square number of pieces. Now look at this. 0 faced cube, or let us say those pieces which have 0 face or no face colored. How do you find them? Where do you find them? Somewhere in the middle, let us say, lying here, maybe. Behind these one face colored, behind these, or let us say below these one face colored cubes. So when you remove the top and bottom, remaining is n minus 2. When you remove left and right columns, you get n minus 2. And when you remove the columns in the front and back, again you get n minus 2 there. So n minus 2 number of pieces we will get on removing the top bottom row, the left right column, the front back columns. N minus 2 in 3 different directions. So n minus 2 into n minus 2 into n minus 2, that is n minus 2 whole cube. Now this will give you the number of 0 faced cubes. Now see how simple and easy this becomes. When you know that for this diagram there are 9 cuts made, 3 in each direction. So in each direction, on each edge, in each row, in each column, the number of pieces is going to be 4. So total number of pieces, well, 4 cube, that is 64. 3 faces colored, always 8. 2 faces colored, well, 12 into 4 minus 2, that is 12 into 2, 24. 1 face colored, 6 into n minus 2, that is 4 minus 2 whole square. 6 into n minus 2 whole square, that is 4 minus 2 whole square. 4 minus 2 is 2, 2 square is 4, and 6 into 4 will be again 24. N minus 2 whole cube is nothing but 4 minus 2 whole cube, because the value of n here is 4. So 4 minus 2 is 2, and 2 cube is 8. So without drawing any diagram, you can find out these details, as you can observe in the previous question which is there. Now let's have a look at a question here. Based on these formulas, you can find out all these details in a matter of few seconds. If all the faces of a cube whose edge is 5 centimeter, what is this? Edge is 5 centimeters means the value of n will be 5. Why? Because then it is cut into small cubes, each of edge 1 centimeter. How many 1 centimeter are there in 5 centimeter? Obviously, there are 5. So the value of n here will become 5, because on each edge you will find 5 small pieces, one above the other, each of 1 centimeter edge. 1 plus 1 plus 1 plus 1 plus 1, 5. So there is absolutely no need for diagram. Question is, how many pieces will be there in total? That we know is n cube, which is 5 cube. That works out to be 125. You don't have to draw the diagram. How many pieces will have 3 faces colored? Well, always 8. No difference there. How many pieces will have two faces colored? Well, the formula is 12 into n minus 2. So here it shall become 12 into 5 minus 2. 5 minus 2 is 3. 12 into 3. That should give us a 36. So how many pieces have one face colored? The formula is 6 into n minus 2 whole square. The value of n is 5. So it is 6 into 5 minus 2 whole square, which is 6 into 5 minus 2 is 3. So 3 square. So 6 into 9, which is 54. And how many pieces have no face colored? Invisible cubes. The formula is n minus 2 whole cube. That is 5 minus 2 whole cube. That is 3 cube, which is going to be 27. So very easily you can find out these details without shaking your confidence within no time and absolutely accurately. Alright, instead of the edge being 5 centimeter, if the edge would have been 7 centimeters. So 7 centimeters, and we have made certain cuts to this cube such that on the edge we have 1 centimeter small cubes. So the value of n will become 7 because on each edge we will have 7 number of 1 centimeter edge cubes. That is 1, 1, 1, 1, 1, 1, 1. Added all to 7. So n is 7. Now find out these details. So how many cubes will be there in total? Well, 7 cube, which is 343. You don't have to draw a diagram. So how many have 3 faces colored? Well, always 8. How many have 2 faces colored? That is 12 into 7 minus 2. 12 5s are 60. So how many have 1 face colored? Well, 6 into 7 minus 2 whole square. That is 6 into 5 square. 5 square is 25. 25 into 6. That is 150. And how many have no face colored? That is n minus 2 whole cube. That is 7 minus 2 whole cube, which is 5 cube. And that is 125. We don't need to draw a diagram. So just by applying these simple formulas that I gave you here, you should be able to solve the questions. So once again, total number of cubes shall be n cube. 3 faces colored, always 8. 2 faces colored, 12 into n minus 2. 1 face colored, 6 into n minus 2 whole square. And no face colored, n minus 2 whole cube. Now, a cube is colored with red, green and blue colors in such a way that each pair of opposite faces has the same color. And then the cube is divided into 64 identical pieces. So if you have to divide it into 64 identical pieces, you know that 64 is 4 cube. That is, n cube is the total, which means the value of n is 4. That is, on each edge, in each row, in each column, the number of pieces will be 4. So let us have a look at the diagram here. Now the questions are as follows. Now here it is given that opposite faces, they have the same color. So let us say that this face, front face is colored red. So back will also be colored red. Top is colored green. So let us say bottom will also be colored green. And right is colored blue. So left will also be colored as blue. Then how many pieces will be colored red? Now you see this front face and the back face consist of those pieces which are colored red. And the number of pieces on a single face shall always be n square. Obviously, see, one face of a cube is a square. Each face of a cube is a square. And how do you find out the area of a square? Well, it is n square, or call it a square, or call it x square. So, on this face, total 16. So 16 in the front, 16 at the back, we will have 16 into 2. That is 32 pieces which will be colored red. So how many pieces have all the 3 colors? Well, all 8 pieces have. Well, all the corner cubes will have the 3 colors on them, and corner cubes are 8 in number. So all of them will consist of this red, green and blue colors. So how many pieces will not be colored? Will not be colored means what? Well, these are zero facet or invisible cubes, isn't it so? So the formula for that is n minus 2 whole cube. The value of n here is 4. So it is 4 minus 2 whole cube, which is 2 cube. which again works out to be 8. How many pieces will not be colored red? Quite simple, you don't have to count. See, there are 64 pieces in all, out of which 32 are colored red. So the remaining 32 will not be colored red. So how many pieces will be colored only red and green? See, only means nothing else. That means not blue. So you look at the edges which are common to the faces which are colored red and green. And when it says only red and green, that means it talks about two colors. So these are going to be two faces colored pieces. You will find that these are those pieces, as you can see, which have only red and green color on them. See, these two and these two. Green is at the bottom. So on one face you have 4 such pieces. So in the back face also these 4 will be there. So there has to be 8 number of such pieces which are colored only red and green and not blue. The next question is, how many pieces will be colored red and green? The only word is not there. So when it says red and green, then blue may or may not be there. So once again we look at all those edges which are common between red and green. Well, there are 2 edges here. This is an edge which is common between red and green. This is another edge which is common between red and green. So 2 edges here and 2 edges at the back, 4 edges. Now each of these 4 edges has 4 cubes or 4 pieces. So total 16 pieces will have red and green. Some of them have only red and green, that is 8. And the other 8 have red and green along with blue. Because the word only is not there, so there is no restriction or no limitation on the inclusion of that piece which has blue color on it. Now how many pieces will be colored only red? Well, these are the ones which can be colored only red, as you can see. Only red would mean only one color. One face colored pieces are found in the center of a face. So 4 here in the front, 4 at the back. That is 2 into n minus 2 whole square. Remember, n minus 2 whole square is the number of one face colored cubes on a single face. On 6 faces, it is 6 into n minus 2 whole square. So we need to find out for 2 faces, because there are 2 faces which are colored red. The front face and the back face. So on the front face we have 4. On the back we have 4. So works out to be 8. You could have used this formula, which would be 2 into 4 minus 2 whole square. 4 minus 2 is again 2. So 2 into 2 square, 2 into 4, 8. How many pieces have red color on only one face? Well, all the pieces which have red color on them have red color on only one face. None of these 32 pieces actually which have red color on them, none of these 32 pieces have red color on 2 faces or 3 faces. Not possible. So how many pieces have only one color on them? Well, only one color, you know, is 6 into n minus 2 whole square. In this case, it shall be 6 into 4 minus 2 whole square. That is 6 into 2 square, which is 4, which works out to be 24. And how many pieces have only 2 color on them? Only 2 color, you know, is in this case 12 into n minus 2. That is 12 into 4 minus 2, 12 into 2, which is 24 again. So when the opposite faces of a cube have same color on them, then we have 10 different ways of assessing them, as we have seen from question number 21 to question number 30. Now look at another case. A cube is colored with red, green and blue color in such a way that 3 pairs of adjacent faces have the same color. See, the previous 10 questions were based on a cube wherein opposite faces were colored the same. Here, adjacent faces are colored the same. Adjacent, like this, you know. And then the cube is divided into 64 identical pieces. Then how many pieces will have so and so? Questions will be asked. First, let's have a look at the diagram here. And the way the colors are arranged. See, this front is red. Even right side is also red. Adjacent, you know, having a common edge between them. Let us say this is green And then on the back also we have green. And this is blue. Then on the bottom also we have blue color. So adjacent faces will have a common edge between them. And when the total number of pieces is given to you as 64, we should now immediately know that the value of n is 4. That is 4 number of pieces on each edge, in each row, in each column. Now look at the questions. The questions are the same, but the answers are not, because the arrangement has changed. Now, how many pieces will be colored red? Well, you know, on single face we have 16. So 16 into 2, 16 in the front, 16 on the right hand side. But these 4 are common here, as you can see. This edge is common. So these 4 cubes you have counted twice. So 16 into 2 minus 4. That is 32 minus 4, which works out to be 28. So there are 28 pieces which are colored red here. Now what is the difference? A common edge which has certain pieces which have been counted twice in 16 into 2. Look at this one. This is colored red here, and green at the top, no blue. In fact, 2 faces are colored red here. So can't say 8. Can't say 0. Because you have a green here, this is a red colored face, and this is a blue colored face. So you have this with you, a piece which consists of all the 3 colors. Now, a simple way of looking at it would be to observe the pieces which are colored red. Look at this one. This is red, and again below this you have green. Now see, this has 2 red and green. This also has 2 red and green. So these are 2 reds, and below that there is a face which is colored blue. And at the bottom you have 2 red and 1 face colored blue. So this cube at the bottom has 2 faces colored red and the bottom face here colored blue. Now you have 1 piece here with 2 faces red and 1 green. 1 piece here with 2 faces red and 1 blue. So you should have 1 red green, a corner cube having 3 faces colored, but 2 faces having same color. So 2 reds and 1 green. Then you have also identified 2 reds and 1 blue. Well, if that may be the case, then definitely there would be a piece at the corner which will have 2 faces colored green and 1 red, 2 faces colored green and 1 blue. Similarly, there would be a cube in the corner which has 2 faces colored blue and 1 red, then 2 faces colored blue and 1 green. Now what are we left with? A cube which has all the 3 colors, red, green and blue, and another one which has red, green and blue. So this is the complete detail of the corner cubes bearing these 3 colors, and you find that there are only 2 such pieces at the corner which have all the 3 colors on them. So our answer here shall be 2, and these are those 2 cubes, 1 here and 1 right opposite to it here. That is, this is red, this is green, and this is blue. So 2 corner cubes here, as you can see. Whereas in the previous case, we had all the 8 corner cubes consisting of 3 different colors. But because here in this case there are 2 adjacent faces consisting of same color, that is why some of the corner cubes have 2 colors only, that is 1 color on 2 faces and the third face consisting of a different color. How many pieces will not be colored? Well, we know these are 0-faced cubes, that is invisible cubes, and the formula for that is n minus 2 whole cube. The value of n here is 4. So 4 minus 2 whole cube, that is 2 cube, which is 8. This does not change. It remains the same. Reason? Well, we are talking about those pieces which have no color on them. They're right in the middle. Whatever is happening outside, they're not bothered about it. So whether the opposite faces get colored the same or the adjacent faces have the same color, it doesn't bother them because they're inside. So the color will not reach them. So in the previous question also, the answer to this question was 8. In this also it is 8. So how many pieces are not to be colored, will not be colored red? How many pieces will not be colored red? Well, how many pieces are there in all? 64. How many are colored red? Well, 28. So the remaining 36 will not be colored red. 64 pieces, 28 colored red. So remaining 36 not colored red. You don't have to literally count. So how many pieces will be colored only red and green? So only red and green would mean not blue. Now again, only red and green here also means those pieces which have only two faces colored red. One face is colored red, the other is colored green. Now these would be found on common edges between red and green. Well, this is one common edge. We will take these two because this is red and this is green. Then these two here, this is red, this is green here. Now even the others. Well, before that, let us determine how many pieces will be colored red and green irrespective of blue. That is, let us look at the common edge. How many pieces do we get? Well, this is a common edge. We go like this and then we come like this. This is what we are talking about. Now how many pieces are these? Well, 1, 2, 3, 4, we have counted this. So this is 5, this is 6, this is 7, 8, 9 and 10. Well, out of these 10 pieces which are colored red and green, we will take out these two pieces which are colored red, green and blue, so that the remaining 8 have red and green on them but not blue. So those which have only red and green but not blue shall be 8. After taking out these two corner cubes which have all the three colors on them. We don't want blue here because of the word only. Now some more questions on this. The next one is, how many will be colored red and green? Well, recently we found out that there are 10 which will be colored red and green on the edges which are common here between red and green, and these are the ones. So 1, 2, 3, 4, once again 5, 6 and 7, the 8, here 8, this is 9 and the last one is 10 here. So how many pieces will be colored only red? Well, we have these 4 here and then obviously 4 here also, which are one face colored cubes. But then what about these 2 face colored cubes here? Even they have only red color on them and no other color. So this shall become 4 plus 2. These are 2 face colored cubes. That is a total of 10. Now how many pieces will have red color on only one face? Well, first of all, how many pieces have red color on them? Well, there are 28 pieces which have red color on them. Out of which, these are those 4 pieces on the edge which have red color on 2 faces, because they belong to the common edge between the 2 adjacent faces which have been colored red. So out of these total 28 pieces, there are 4 pieces which have red color on 2 faces. So the remaining 24 pieces will have red color on only one face, not on 2 faces. So how many pieces will have only one color on them? Well, only one color on them. We first will take the center cubes, the one in the center. The formula for that shall be 6 into n minus 2 whole square, because on each face you will have these center cubes which will bear only one color. Plus, as you saw here, there are 2 pieces which have only red color on them, but these are 2 face colored pieces found on an edge. So you will have 2 such for red color, 2 such for blue color and 2 such for green color. Obviously it's going to be symmetrical. If there are 2 cubes on an edge, the common edge between the adjacent faces which have been colored red, so these 2 pieces will have only red color on them on both the faces. Similarly, 2 pieces which are common between the 2 adjacent faces which have been colored green will have only green color on them on both the faces. Similarly for blue. So this shall be the the value of n here is 4. So 4 minus 2 is 2. 2 square is 4. So 6 into 4 plus 6. That is 24 plus 6, which happens to be 30. So there are going to be 30 pieces which have only one color on them. So how many will have only two color on them? Only two colors? Well, in this case, we know usually we take the two-face colored cubes which are found on the edges. The formula for that is 12 into n minus 2. Out of which you will remove those two which have only red color on them, like these two. Alright, although these two are two-face colored cubes, but they have only one color on them, that is red. So 2 green also and 2 blue also will be gone. Plus, you will attach those 6 corner cubes which have 2 color on them. Remember, those were red, red, green, red, red, blue, 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 green, blue, blue, red, green, green, red, green, green, blue on the previous slide. So those 6 have only 2 color on them. So 6 here gone, 6 here cancel. So it shall be 12 into 2, which is 24. In this case, it remains same. But for 125 cubes, for 216 cubes, it won't be the same. Now we found out these details for a cube, wherein the length, breadth, height of a cube is always the same. Or let us say, along the length, along the breadth, along the height of the cube, we will have same number of pieces. But what if it is a case of a cuboid? Well, it is quite simple. Although I'll give you formulas, but they should not be called formulas, they should be called expressions. And obviously you don't have to mug them up, you have to understand them. Now when 3 pairs of opposite faces of a cuboid are colored with 3 colors, and the number of cuts made are different for each direction, then the number of pieces on each edge will be different. Then to find these details, what you have to do is, number of pieces on each edge shall become different, that is n1, n2, n3, because length, breadth, height of a cuboid, all these 3 figures will be different. We are taking that particular case. There could be 2 figures which could be same also. So we have different counts of pieces on each edge. Now total number of pieces, again we know that in case of a cube it was n cube. Now what is n cube? N into n into n. Now n happened to be the same, so hence it became n cube. But here n is not the same. It is n1, n2, n3. The multiplication of these 3 will give us the total number of pieces in this cuboid. Well, 3 faces colored will always be 8, provided adjacent faces are not colored the same. Opposite faces are colored the same, let us say. 2 faces colored. Well, what was it? For a cube, it was 12 into n minus 2. Actually speaking, there are 3 directions, I told you. Vertically perpendicular, horizontal, and vertically parallel. So this was in actual 4 into n minus 2 for, let us say, vertically perpendicular, then 4 into n minus 2 for vertically parallel, and 4 into n minus 2 for horizontal plane. Now, as this n happened to be the same everywhere, we added up these figures and it became 12 into n minus 2. But now, that is not the case. So, it shall be 4 shall be taken common here, n1 minus 2 plus n2 minus 2 plus n3 minus 2. The sum of these multiplied with 4. So it's just to understand. Alright, again, you please don't have to mug this up. Try to understand. Only difference is that the value of n is different now. It is n1, n2 and n3. Instead of throughout being n for length as well as for breadth as well as for height. So that is the only difference. 1 face colored. Well, what was it? In case of cube, it was 6 into n minus 2 whole square. Well, we removed the top and bottom, n minus 2. We removed the left and right column, it was n minus 2. But the count now is not the same. So it was initially for one single direction, it was 2 into n minus 2 into n minus 2. Plus for the other direction, 2 into n minus 2 into n minus 2. Plus for the third direction, 2 into n minus 2 into n minus 2. Here, the value of n was common. It was the same throughout. So, hence it became 6 times n minus 2 whole square. Now, for the case of cuboid, it is not this. So, 2 I have taken here as common from this. As you can see, 2, here also 2, here also 2. Then n1 minus 2 into n2 minus 2 plus n2 minus 2 into n3 minus 2 plus n3 minus 2 into n1 minus 2. We will solve a question on this. Don't have to worry about it. Zero face is colored. What was it? It was n minus 2 whole cube. Where did that come from? For 3 axes or 3 directions, it was n minus 2. For n minus 2, again into n minus 2, and was same, so n minus 2 whole cube. So n1 minus 2 into n2 minus 2 into n3 minus 2. Now let's have a look at a question here. A cuboid whose length, breadth and height are 3 centimeter, 4 centimeter and 5 centimeter respectively are cut into identical pieces of equal edges by making 2, 3 and 4 cuts in 3 different directions. Now in this cuboid, the smallest faces are colored red, the largest faces are colored green and the remaining 2 faces are colored blue. Actually, you don't need a diagram, but still, for the sake of understanding, I will provide you with one. Let us say this is the cuboid. Here, this is 5 centimeter length. This length is 4 centimeter. And the breadth here is 3 centimeter. Now we have to make 2, 3 and 4 cuts. Now here, as per this, we have to make sure that they are cut into identical pieces of equal edges. And the only equal edges that can come here for the small pieces shall be 1 centimeter. Because the number of cuts are given to us, so this is 4 centimeter, should be divided into 4 parts. 3 cuts will divide this into 4 parts. So we'll make those 3 cuts. Well, this is 5 centimeter. This needs to be divided into 5 parts of 1 centimeter each. So 5 parts we can obtain by making 4 cuts. So let us make 4 cuts to this. Now this one, this much is 3 centimeter, is to be divided into 3 parts. So 2 cuts would suffice to cut this into 3 parts or to divide this into 3 parts. There we go. Now he says here, the smallest faces are colored red. Now which will be the smallest faces? Well, those with the area 3 into 4. So this you know is 3, this much you know is 4. Here this is 3 into 5, right? So this face will be bigger. So these are the smaller faces, that is the top ones, red at the top, red at the bottom. Largest faces are colored green. So largest are the ones which will have the area 5 into 4. Isn't it so? So that is the front and the back shall be colored green. And the remaining 2 are colored blue. Those are these, the left and right. Now look at the questions. So how many small pieces have only one color on them? Well, how do you find out only one color on them? First of all, you will have to know this, that this is your N1, this is your N2 and this is your N3. Number of pieces here 3, number of pieces 4, number of pieces 5, each consisting of 1 centimeter edge. So only one color, we already know that it is 2 times N1 minus 2 into N2 minus 2 plus N2 minus 2 into N3 minus 2 plus N3 minus 2 into N1 minus 2. Well, seems very tedious, but when you solve this, it shall become very simple. So when we know that your N1, N2 and N3, these are 3, 4 and 5, then your N1 minus 2, N2 minus 2 and N3 minus 2 shall become 1, 2 and 3. Now just substitute that here, these values. So it becomes 2 into 1 into 2 plus 2 into 3 plus 3 into 1. How simple is that? Now this is equal to 2 times 1 into 2 is 2 plus 2 into 3 is 6 plus 3 into 1 is 3. So 2 plus 6 is 8 plus 3 is 11 into 2. We should get 22 such cubes which have only one color on them. Now other way around, if you want to actually count them, well, 1, 2, 3, 4, 5, 6 here. Then 1, 2, 3 here. So 6 plus 3, 9. Then 1, 2 here, that is 11. So 11 on these 3 faces. So on 6 faces, 11 into 2, 22. But you don't need to. Actually, you don't need this diagram also. You just require these values. So how many have only 2 colors on them? Now what's the formula for that? Well, it was 12 into n minus 2. Isn't it so? But then we worked it out and we found that it was 4 into n1 minus 2 plus n2 minus 2 plus n3 minus 2, which shall work out to 4 into 1 plus 2 plus 3, that is 4 into 6, which is nothing but 24. That's it. See, while doing calculations, performing calculations, this becomes very simple now. You don't have to actually mug it up. You just need to know this. Well, how many have all the 3 colors? Well, there is no doubt about it. All the 8. Because adjacent faces do not have the same color. It is the opposite faces which have the same color. In such a case, each of the corner cube will consist of all the 3 colors. So how many have no color on them? Well, what was the formula for that? It was n minus 2 whole cube in case of cube. Whereas here, it is n1 minus 2 into n2 minus 2 into n3 minus 2, which shall be 1 into 2 into 3, which is equal to 6. Now, how many pieces are colored red? Well, find that out. Red is at the top here. That is 3 into 4. So, 2 times, because there are 2 faces which have red color on them. So, 2 times 3 into 4. Now, that again should become a 24. 12 at the top, 12 at the bottom. These are the 24 cubes which have red color on them. Now, how many small pieces are colored green? Now, you remember the largest faces are colored green. So, the largest area here shall be 5 into 4. And there are 2 such faces. So, that is 20 into 2, which should give us 40. How many pieces are colored blue? Blue color was, if you remember, it was 5 into 3. Just for your knowledge, once again, if I may just give you an idea, because the diagram got left on the previous slide. Well, this is 3, this is 3, this is 3, right? This is 4, this is 4, this is 4. This is 5, this is 5, this is 5. And this is green at the back, red at the top and bottom, and blue left and right side. So colored blue is, as you see, 5 here and 3 here, 5 into 3. Colored green, as you saw, 5 here and 4 here. And there are 2 faces, so 5 into 3 into 2, which shall become 30. Now, how many pieces have only green and red color? Only green and red, which means not blue, which means we want 2 face colored cubes here. Well, as we can see, the edges which are common between green and red, they have 4 small pieces on them, out of which 2 will be the 2-faced cubes, right? Because it is n1 minus 2 or n2 minus 2 or n3 minus 2 that we take here. So here it is n2 minus 2, and there are 1, 2 such edges here in the front, and 2 shall be at the bottom. So n minus 2, that is 2 into these 4 edges, is what we get here as 8 pieces, which will have only red and green color on them, but not blue. How many are colored blue and red? Now, blue and red will be on this edge, that is these 3. So 3 at the top, 3 at the bottom on one face, and then 2 more such 3 and 3 on the other face. So 3 into 4 edges should give us a 12. Now, what will be the total number of small cubes? Now, that we already know is n1 into n2 into n3. That is 3 into 4 into 5, which shall be 60 in all. Alright guys, so I hope that you have enjoyed this session on cubes and cuboids. We will meet again in another discussion. Till then, I wish you all the best. Stay safe. And thank you so much.